truth functions, section 6.2. This word here, function, is very important. What that means is you can determine the truth value of a compound proposition if you know the truth value of the simple components, of the simple statements that have been combined with connectives or operators, right? To form a compound proposition, you can know the truth value of the whole compound proposition if you know the truth value of the simple components, because the truth value of the compound proposition is a function, is dependent, is determined by the truth value of the simple components. So that's what they mean by truth functions, okay? So I'm going to repeat this by reading what's on your handout here. The truth value of a compound proposition expressed in terms of one or more logical operators is said to be a function of the truth value of its components. This means that the truth value of the compound proposition is determined by the truth value of its components. And if the truth value of the components are known, and in the examples I'm going to give you in the book, either they're given to you, like A, B, and C are true, D, E, and F are false, or you may have a sentence like George Washington was our first president and John F. Kennedy was our second president. Well, George Washington being our first president, we would know that's true. John F. Kennedy being our second president, we would know that that was false, right? So you don't have to worry. These will be given to you, or you'll be given enough information in the situation to know what the truth value of something is, or even if it matters. You'll understand that later. But if the truth value of the components are known, then the truth value of the compound proposition can be calculated from the definitions of the logical operators. Okay, and the definitions of the logical operators, they're right here. And don't get too confused by the word. They call them, you know what they call these? These are truth tables, charts here. In these tables, they call these definitions of the operators. So here's negation. This is the definition of the negation operator. Here's the definition of the conjunction operator, disjunction. Down here is hypothetical, and then you have your biconditional. And the way these work is, once you know the truth value of your P, like if you're dealing with a negation, right? If you have roses are red, if that's true, right, then you know that not R, roses are not red, that would be false, right? If R is true, not R is false. So this is what these tables do. So here, if you have P is true, remember P could stand for anything. Let's just say it's you know, roses are red, right? If P is true, then not P is false, right? If P, whatever it is, you decide that it is false, not P is true, okay? So if you're coming over here to the conjunction, here's the conjunction. The truth value of the conjunction is dependent on the truth values of the conjuncts. So P is the left conjunct, Q is the right conjunct. If you know P is true and Q is true, then the conjunction is true. You're saying both P and Q. If both are true, then, you know, you remember the truth value of the compound. Here's the compound statement, which is a conjunction. Its truth value is dependent on what these little guys, these simple components, are. So if P is true and Q is true, the conjunction is true. If P is true and Q is false, the conjunction is false. If P is false but Q is true, the conjunction is false. And if P is false and Q is false, the conjunction is false because it's dependent on the simple components. And I have a little rule here. For a conjunction, both have to be true. Both conjuncts have to be true for the conjunction to be true. If you don't see two truths, and you see true false or false true or false false, the conjunction is not true. And let's do it this way. If you have both roses are red and daisies are yellow. Okay, let's just say we wrote that all out into a sentence. And we call roses are red as R, and daisies are yellow. We'll call that Y. Okay? I want you to realize if you had something like this, roses are red and daisies are yellow, the roses are red is the P, right? You remember P is a variable. It could stand for any kind of proposition. So here, roses are red is the P. Daisies are yellow is the Q. Okay, so if you're looking at that, you want to see, even though it says roses are red and daisies are yellow, this is the P and this is the Q. Now roses are red, okay, that's true, and daisies are yellow, that could be true, so that would mean this here, the P is true, the Q is true, so the conjunction is true. Alright? But let's say for whatever reason you said roses, the roses you have in your hands, they're not red. Let's just say this was false. Okay, and this Q was true. So you'd want to be able to see that the P is false, it would be right here. The Q is true, you'd be at the third row, and that would make the whole conjunction false. So what I'm trying to have you guys realize is when you see ordinary sentences, look for the P's and look for the Q's, okay? Now, over here, the disjunction, if you know the main operator's a disjunction, then with disjunctions, you just have to have one of the disjuncts to be true. So at least one. So true, true, you have at least one, it's true. True, false, it's true. False, true, it's true. The only time a disjunction is false is when you have both false and you don't have at least one true. So only one of the propositions needs to be true in order for the disjunction to be true, because what the disjunction is saying really here is at least one is true. Okay? The hypothetical, if you have if P then Q, and if whatever you're looking at, if you have an antecedent, this is the antecedent, the P is the antecedent, whatever it is. The Q is the consequent, okay? If you know the antecedent is true and the consequent is true, the conditional is true. If the antecedent is true and the conditional is false, the conditional is false, and I'll explain this in a minute. If you know the antecedent is false and the consequent is true, the conditional is true, and if the antecedent is false and the consequent is false, the conditional is true. Now this may be a little weird. You're looking at this and going, okay, those other ones can make sense, but what about this here? Here's why. Let's say I get up in front of the class and I say, hey everybody, if it's raining outside, then the streets are wet. I'm telling you a true fact about life. And you go, oh, thank you, Dave, we didn't already know that. So Dave, you're saying if it's raining outside, the streets are wet. And this is a true statement about reality. Thank you, Dave, we already knew that. But that is true, right? So let's come up here. Remember, the P is the antecedent. So the antecedent, this is the P. P is, it's raining outside, okay? You got to get used to seeing the P's and Q's. So if I said it's raining, if it's raining outside, then the streets are wet. If it is raining outside is the P, right? And the P is it's raining outside. Then the streets are wet. This is the Q because it's the consequent, and the Q here happens to be streets are wet, right? Okay, you guys get that? So if I say if it's raining outside, the streets are wet, it's raining outside is the antecedent, this is the P. If the streets are wet, this is the Q, the consequent. Okay. Now, this first row, so I've stood up in front of the class and I've said, hey, If it's raining outside, the streets are wet. Thank you, Dave, for giving us that true fact of life. We didn't already know that, but thank you anyway. Okay, but actually, it's more significant than it sounds. So let's go up here. If it is really raining outside, that's true, and the streets are really wet, this means I wasn't lying to all of you, that my conditional, if it's raining outside, the streets are wet, is true. That's why this is true. But what if it really is raining outside? It's true, but the streets are not wet. The consequent is false. That means I wasn't telling you the truth when I said if it's raining outside, the streets are wet. This would falsify my handy tip for life, right? So if it really was raining but the streets were not wet, they were dry, my conditional in the beginning, if it's raining outside, the streets are wet, I was lying to you. But let's say it's not raining, because this is the P, it wasn't raining. Raining outside is false, but the streets are wet. Did this mean I was lying to you when I said when it rains, the streets are wet? No. Because if it's not raining, I never said streets can only be wet when it's raining. There are other ways streets can be wet, right? A fire hydrant, sprinklers, they shot a movie on your street the night before and got the street all wet. So if it's not raining, but the streets are wet, this doesn't mean I lied to you initially when I said when it rains, the streets are wet. This is why that conditional in the beginning, this one here, hasn't been falsified. And let's look at this scenario. If P is false, it's not raining, and Q is false, the streets are not wet, the reason the conditional is true is that in no way falsifies the fact that I said when it rains, the streets will be wet. Okay? So that's how that works. And just realize these P's, what this does, this truth table, it gives you all the different combinations. What if P is true and Q is true? There it is. Okay, Dave, I bet you haven't written them all down. What if P is false and Q is true? Oh, there it is. Well, what if P is false and Q is false? That got you there. Well, what if P is true and Q is false? These are what the statistician geeks, so to speak, if you ask them, what's a quick way to write down all the different combinations? And that's what these definitions are. These are tables. They call them definitions of the operators, okay? And then for the biconditional, if both are true or both are false, then the biconditional is true, and if they're different, the biconditional is false. Okay, so those are the definitions. Let's go back to the first page again. All right, so if you have the definitions of the basic logical operators, which is right here, if you have this on hand and you understand it, and you know what the various P's and Q's, their truth values are, and remember I told you the book will just give them to you one way or the other, you can determine what the overall truth value of a compound proposition is from the truth values of the simple components. Okay, now this section here, this is basically kind of reiterating what you probably already know. Okay, so the logical operators, you're given variables. Here they are. The P, for a negation, you just have one proposition, right? P and Q, these are two variables. Sometimes you could have more, but the variables here, that's what they're talking about. Whatever the propositions are, whatever P stands for, whatever Q stands for. So when you have those variables, and they can stand for anything, like P could be apples or red. If apples are red, then they are juicy. B could be fruits that are juicy. Or B or C could be either juicy fruits or cats are furry, I don't know, something like that. So when you have these variables, and they're used along with operators, so if you have if P then Q, or if you have either A or B, if you put the variables together with a statement form, with the operators, you get a statement form. So this is called a statement form. This is kind of simplistic and redundant. And then you substitute these variables. Actually, I probably should have just used it with the variables P and Q. If you have P, it could stand for anything. If you have a Q, it could stand for any kind of proposition with an operator or a connective. This is called a statement form. And then when you substitute P or Q for any kind of proposition, then you have basic compound statements. And I did that previously. Remember, P was if it's raining outside, and Q was if the streets are wet. That's what we mean by that. Okay, so then you can substitute these statement forms with real propositions, and then you have compound statements. Okay, so all this, I hope this is going to click now, because I'm going to show you how you can have a compound proposition given the truth values of the various simple components, and they'll be represented by letters, and you'll be able to determine the truth value of the compound proposition, because you remember the beginning here, it's a function. The compound proposition truth value is a function of the simple components. Okay, so here's what you do. I'm going to give you let's see, let's go here. Okay, we have either A or if either A or D, then E. Okay, I want you to remember that. Let's go back to these steps. Here's what we're going to do. And this will all start coming together. I realize I keep giving you stuff that's prepping you and you don't quite know what all this is used for. Well, hopefully this will help now. Okay, so let's consider each operator definition given by a truth table. We've done that. And here's how we'll compute the truth value of longer propositions. Okay? First of all, you write the truth values under the letters for the simple components. Okay? So remember, if we know the truth values of the simple components, we will be able to determine the truth value of the compound proposition, because it's a function of it. Determine what the main operator of the compound proposition is, and then use these truth values with the definitions of the operators, the tables I showed you, to compute the truth values of the compound components. And write this truth value under the main operator of the component you were working on, and you want to go ahead and circle it. Okay, let's go to the next page and I'll show you how this works. Okay, here is our compound proposition, right? Compound proposition. Okay, and it's if either A or D, then E. And here, remember I told you the book is going to tell you what the truth values of the simple components are. A is a simple component. It could be apples are red, and D could stand for dumplings have starch. Then E could stand for earthworms are good for the soil. I don't know, okay? But here it's saying A, B, and C are going to be true, and D, E, and F are going to be false. So go ahead and write under this. Here, let's do different color here. Okay. So A is true, and D we know is false, right? These are the simple components. They are standing for simple propositions. A compound statement is when you connect simple statements by connectives, and we have a wedge connective, a disjunctive connective, and we have a horseshoe, right? E is false. Okay? All right, now let's go to our definition of the operator, because we're going to need to use this. See, we already know what E is. E is false, and we know what the main operator is. This is a conditional. So we've got to just decide what either A or D is if A is true and D is false. Now, I want you guys to notice something. Do you realize this is a conditional? You realize the E, earthworms are good for the soil. This is the Q. Q is a variable and happens to be the consequent. This whole thing here, if A then D, this is the P, right? P is the disjunction. Horseshoe Q. Q, it's pretty simple. It's earthworms are good for the soil. We know it's an F. But we don't know right now what P is. But I want you guys, when you look at this, see the Q's all the time. See the P. Remember I said P can be anything? P happens to be a disjunction here. So, either A or D, this is a disjunction. Within the parentheses, it's a disjunction. So and if we had a disjunction over here, A or D, for the conditional, the whole thing is the P and this is the Q. But for a disjunction, can you see that the A is the P and the D is the Q? Okay? So let's go to our definition, our operators, definition of the operators, and I'm going to clear the ig from this. Okay. Since we're dealing with a disjunction, and let's go back a minute here so I remember. Okay, A is we have true, false, true, false. The P is true. The Q is false. Okay, so let's go back over here. Here we are. We're at the disjunction. You'll use this one here, and P is true, and the Q is false. That means the disjunction is true. Okay, you've got to see the second row is going to help us. Let's go back over here. When you're dealing with a disjunction, true, false, it means the disjunction is true. Now, what are we going to write under the main operator? Okay, well, we go to the conditional one, and if the conditional is true, if the P is true, right, and the Q is false, let's go to the conditional one now, or it's called the hypothetical. And we know the P is true and the Q is false. That means the hypothetical is false. So we go back there, and it's false. So you see, we know that this whole compound proposition, its truth value is false, but we found it by knowing what these simple components were. A was true, D was false, E was false. We found out the main operator was a conditional. We already had the antecedent, the Q of the conditional. We needed to find out what the antecedent of the conditional was. This is the consequent. I'm sorry if I said antecedent. And we realized with the disjunction, the antecedent of the conditional was true. And so true, false on the chart for the conditional, it is false. Okay, let's go ahead and do this second one here. Okay, so B we know is true. B is true, C is true, A is true, and E is false. And remember, we know that because of right here, right? They just tell us. All right, the main operator, it is a horseshoe, so it's a conditional. And for the conditional, you guys all realize this is the Q, and the Q happens to be a conditional. Q can stand for anything. This is the P for the conditional. So we want to know what the P is, true or false. We want to know what the Q is. So to find out what the Q is, since it's a conditional, we need to go to the conditional operator. And the conditional operator, we have false, true, and you got to remember, if you have if E then A, the E is the P, the A is the Q, and we know the E is false, the P is false, and the A is true, the Q is true. So on our chart, we want to find a row where P is true and P is false and Q is true. So FT. And so let's go down here, and lo and behold, here's F. P is F. The Q is true. The conditional is true. So we'll go back. We'll come down. And so the Q, if we have a conditional where P is F true, P is F and Q is true, this is true. And remember, if we go, both are true for the conjunction. Here's the P, it's a conjunction. So go to the conjunction when both are true. The conjunction is true. So the conjunction here is true, so the P for the conditional is true, and if we go to the conditional, true, true, we know that this compound proposition, that's true. Okay? So it's true for the whole thing. Okay, let's do one more. And we're dealing with this one. Okay. So let's do our truth values first. C is true. Oh, let's go change this. Let's erase that there. Okay. All right. So C is true, A is true, B is true. Okay, it's a conditional. That's our main operator. Here is the Q of the main operator, right? The Q is a not B. So if B is true, what does not B become? It becomes false, right? So if B is true, not B is false, and not B is what Q is. So you're going to put a false here. Okay? Now, now we're going to go to the other side of the horseshoe. The antecedent is this whole thing. This is the P of the main conditional, right? Okay. So we're trying to determine what P is. If A is now inside the parentheses, it's a disjunction. So start inside the parentheses. If A is true, not A is false. Okay, and cross that out. And C. So you have C is true and not A is false. So if we brought this over here, if you had C or not A, and C is true, and not A is false, then for, at least inside the parentheses, it's a disjunction, right? So the C is the P, right? The not A is the Q. So we're going to go to the disjunction definitional operator, and we're going to look for a row where it says true, false. So let's go here. Here's the disjunction, row 2, P is true, Q is false. The disjunction is true. And remember, with disjunctions, you're going to get so good at this. I'm only going back to the table for your benefit. I already know here, true, false, that means this disjunction is true. And whatever main operator you're dealing with, like here's the main operator over here for just this. Inside the parentheses, the main operator is the wedge. So if you know what the disjunction is, go ahead and write true. I'm sorry. Go ahead and write true. Well, let's erase that. Okay, sorry about that. Don't want that to confuse you. Let's go back. So under the main operator, it is true. Go ahead and write it under the V. And now, inside the parentheses, it is true. But remember, we've got a tilde. So if it's true inside the parentheses, that means outside the parentheses, it's false. So this whole thing is going to be false, okay? And when you have if false then false on the horseshoe operator now, it's right here, false, false, it's going to be true, okay? So we come back down, and that means this compound proposition is true for that compound proposition with these specific truth values for the simple component. Okay, we'll stop here. Play this over again if you're not understanding, and we'll keep working on this as we do truth tables. Okay? All right.